with parallel lines. We know parallel lines. What do we know about parallel lines? Jake.
There are two lines that go indefinitely but will never touch each other.
Right. So they'll never touch each other. They will never intersect. We're going to throw one additional key phrase, and that is that they have to be in the same plane. Okay, they have to be coplanar, as we call it.
Is it any two lines coplanar?
Not okay.
Oh,
all right.
Oh yeah.
So take, for example, okay, actually let's pretend this classroom is a box. We'll pretend that one, right? So if we take like this line along the ceiling and this wall, and then the floor and this wall, these two lines would be parallel to each other, okay, right? Hopefully those lines would never intersect with each other. Otherwise, what would that mean? That our ceiling would be lopsided and eventually collapse, right? So, yeah, or the floor, or both, right? We don't want that to happen. But let's take the line here, and how about the line in the back of the classroom going up and down?
Mm-hmm.
Will those ever intersect? No.
This one? Can you post chapter 3 on that?
No.
Oh, yeah. All right, so when we have parallel lines, again, they have to be in the same plane. So for example, the line, like if we take these two lines, they're both in the plane that would be this wall with the whiteboard, right? So the way that we are going to show that they're parallel is we put extra arrows on them. So you'll see here and here. To show that two lines are parallel, we just put an extra set of arrows in those lines. And in order to write that they're parallel with notation, we use a double vertical line in between. Okay, so that tells us that they are parallel to each other. Okay, skew lines also never intersect, but the difference between parallel and skew is that skew lines are not coplanar. So they do not lie in the same plane. So we talked about that line going up and down in the back of the classroom, and either one of these lines, those would be skew. Is there a plane that would contain both of those lines? No. So kind of think of, so here's an example. Sorry, Jonah, you can't see on the video, but if I took two pens like this, these are parallel. As soon as I turn this one, now they're skew. Parallel, skew, right? So that's the difference between the two. So there's no notation for skew. We have to just write out the words. So line N is skew to line L. Now you have to kind of picture three-dimensionally, because on our two-dimensional sheet of paper, does it look like these will eventually intersect? Yeah, in a two-dimensional space. But you have to kind of picture if you had like, a tissue box or this classroom, right? This one in the back actually won't intersect. Okay, parallel planes, just what you would imagine. What's an example of parallel planes in this classroom? The ceiling and the floor, the front wall, the back wall, the two side walls, right? They're never going to intersect. And remember, how do we name a plane? We use three non-collinear. So just a quick reminder, when we name a plane, we always use three non-collinear points. And any other points that are in that plane would be implied. So if it says TUY would be this whole plane here, which would also include Z. So that would be that plane. And that would be parallel to VXW. Does it matter the order that we put the letters? No, not with a plane. So here, like the two sides of that box would be parallel. Okay. All right, let's take a look. We have a cube. And we want to name each of the following. Keep in mind, there's more than one right answer. So we want to name a plane that is parallel to ABG. So ABG would be the top of that cube. No? EDC? Perfect. EDC, right? Because EDC will be here. Again, you can use any three of those letters that's in the bottom plane. Okay, how about a segment that intersects CH? CH. EC? Yep, that's fine. EC is fine. Yeah. GH. Basically, all you need to make sure is that it has either a point C in or a point H. So it could be DC, it could be BC, right? EH, GH, any of those segments.
Couldn't we also say it could be like GC? Or
Yeah. So even if a segment is not drawn, the idea is you still could connect them and make a segment. So the example of GC, I don't have a line segment drawn there, but if I did, it would have to intersect. So even if I can draw it and it's not already there, you can use that as an option. Okay, how about a segment that's skew to BG? So here's BG. FE is fine. AD is fine. Okay. We got a number. What about DC?
yes.
EH? We got a whole bunch, right? So if it's skew, we just want to make sure it's not in the same plane, right? And that they're not going to intersect each other.
How does
Okay.
that work if it's a segment? Since it's since it's segment BG, do you just assume it continues?
Yeah, we can assume that it continues. So when we're talking segments and lines, just think we always could extend the line, and if it never intersects, then we would refer to that as skew or parallel or whatever. Okay, we got a new definition here, transversal. Not the same thing as transitive property. Transversal is a line that intersects two or more other lines in a plane, okay? So in one plane. So we got a bunch of new definitions. They are on this sheet of paper. We're not going to do the theorems and postulates until the next couple classes, but we are going to learn the names today. Okay, so the transversal in this case is T. It's not always going to be called T. Just so happened I named it T in this case. So if I have two lines, I have created 8 different angles, okay? And we have separate angle relationships depending on the location of these angles. Now, if I had another line, this would still be the transversal. I would just have another 4 angles that I could look at, okay? So what we want to do is look at the different angle pair relationships. So the first one, interior angles. Okay, so the best description, because we don't have an actual definition here, just the angles between or inside the 2 lines. Okay, so here are our 2 lines, A and B. So kind of think if I were to collapse kind of those 2 lines, all the angles between them would be interior angles. So what angles would those be? 5, 6, 3, and 4. Good. So those would be our interior angles. So of course our exterior angles would just be good. So these are the ones on the outside. 7, angle 8, angle 1, angle 2. Okay, corresponding angles. These, and again, these angles are always going to become pairs. So they have a pair, like a matching you know, like you have a pair of socks or a pair of shoes, right?
Are
So,
interior angles always inside of traverse? Is it always related to transversal?
it's always related to the transversal. Okay, so let me give you a quick example. Like, what if I gave you 3 lines, and this would be my transversal, right? So 1, 2, 3, and 4 would still be considered interior angles. Yeah, but they would be interior angles to lines A and C. So what you have to do is but what about, now what if I'm just looking at lines A and B? Now just 1 and 3 would be the interior angles that I've labeled, okay? So when you're working with pairs of angles, you always have 2 lines and 1 transversal that you have to look at to consider what the relationship would be, all right? Yeah.
So if it was transversal and it was interior angles, how do you know if it's A, B, or B, C?
Oh, you'll see. So basically what we're going to do for the homework then is I'm going to say what kind of angles are 1 and 4, and then I would ask what the transversal would be, because sometimes we might have an extra line here. We might have multiple transversals. Okay.
What would happen at that?
So you have to figure out, according to the pairs, what are the 2 lines and which one is the transversal that is creating that relationship.
Wait,
Okay.
so there's only 2 lines. Even if there's 4, there's
Yeah.
only 2.
So you have to always think in terms of the two lines and the 1 transversal. I try to start off simple with just 2 lines and 1 transversal, and then on the homework you'll have multiple lines. Don't worry, it's fine. There can be multiple transversals. You'll see. Okay, let's just focus on this picture though for now.
Can I go to the bathroom?
Yeah. So corresponding angles, a pair of angles in the same relative position. So it's kind of like if I were to take angles 5, 6, 7, 8, and I were to shift them up here. So what would 5 correspond to? 1. So angle 5 and angle 1 would be a pair of corresponding angles. So again, it's as if you took that group of 4, shifted them over, and they would have, which angles would overlap? So 6 and 2. Angle 7 and angle 3. And there's one more pair, angle 8. Good. So corresponding angles, we have 4 pairs. All right, next. Okay, alternate interior angles. Okay, alternate interior angles, they're a pair of interior angles that lie on opposite sides of the transversal. Okay, so for example, 3 and 6 would be a pair of alternate interior angles.
Would 4 and 5 also?
Yeah, 4 and 5 would also be alternate interior angles. So notice all 4 of those are interior angles, but a pair of them mean they have to be on opposite sides. Also, just one quick note, all of these angles are non-adjacent angles, I should say.
Corresponding?
Even corresponding. So corresponding, alternate interior, alternate exterior, and consecutive interior, which we'll do, none of them can be adjacent to each other. So because angle 3 and 4 would actually be what kind of angles? Linear pair. So, and 5 and 6 would also be a linear pair. So linear pairs can't be any of these. Okay, linear pair is something that we've learned previously.
Wouldn't they also be supplementary angles?
They would. They would.
So why did you decide that they were a linear pair before you decided they were supplementary?
Because a linear pair tells me what they look like.
But so does supplement.
No, supplementary does not
You
need
have
to be
separate.
adjacent, right? Okay. Next one, alternate exterior angle. Along those same lines, a pair of exterior angles that lie on opposite sides of the transversal. Good. Good. 1 and 8. And 7 and 2. All right, last one. Consecutive interior angles. Okay, consecutive means what? Like one right after another, right? So these are going to be a pair of interior angles that lie on the same side of the transversal. Okay, so 5 and 3. So they're both interior, right? The one in, and they're on the same side of the transversal. So good. 6 and 4. Okay. Now we're gonna.
There's no consecutive.
There's no consecutive
What was the
exterior.
second one on the other one?
6 and 4. 3 and 5 and 6 and 4. Okay, so next is what I was talking about previously. Of course, I'm not just going to give you 2 lines in a transversal. Here I'm giving you 4 intersecting lines. Okay, here's line N. This is line P, L, and M, and we have all these different angle numbers. So there's a few things that we want to answer. We want to identify the transversal, okay, that is connecting the pair of angles. And then we're going to classify each pair as alternate interior, alternate exterior, corresponding, or consecutive interior. Okay? So let's look at angle 1 and angle 7. Okay, here's angle 1, here's angle 7. So in each case, we're going to basically ignore one of our lines. Which line can we completely ignore here? Yeah, M has nothing to do with those. So what's our transversal?
L.
L. That's the line that both of them are along. So our transversal is L. And what type of angles are 1 and 7 according to that? Alternate exterior, right? We could see the 2 lines that they're alternate exterior to are N and P. But we just have to establish which is the transversal. So alternate, and we can abbreviate. I am totally fine just abbreviating the first 3 letters. You good with that one? Yeah. Okay. All right. Next one, 2 and 10. 2 and 10. Okay, those, yeah. So I'm ignoring this one. So the transversal is line N. So, and we already said it was corresponding.
Wait, what is corresponding?
So corresponding
That's right.
Corresponding is if you shift these angles up here, they would be in matching positions, we say. They're corresponding. So remember, so think of corresponding like matching, right? If you were to match the pairs of angles. So if I were to take these 4 angles and shift them up here, which ones would match up with each other?
Oh, like they'd be the same.
Yeah.
So 1 and 7, how alternate exterior?
Yeah, those will be alternate exterior.
Wait, why is that?
What's that, Russ?
Do you have to write L and N?
No, you just have to write the identify the transversal. So for 8 and 13, so here's 8 and 13. Now I'm ignoring line N, has nothing to do with it. P is the transversal, and what kind of angles are these? Consecutive interior. Okay, next one is 3 and 11. Okay, 3 and 11. First of all, the transversal is line N. And 3 and 11 are corresponding again. Corresponding. Do we see that? They're in the same relative position. Okay, next one we have 4 and 6.
L.
Good. L is the transversal. And what kind of angles are they?
Alternate exterior.
Good. The nice thing about the terms they're kind of are self-explanatory, right? Alternate, meaning different sides. Exterior. Okay, 7 and 13. P is the transversal. And they are
Alternate
interior. Good. Okay, 2 and 10. N. Corresponding? Good. And the last one on here, 2 and 8. 2 and 8 is L. And yes, alternate interior. Pretty easy lesson, right?